Welcome to AI for Specialists. Today we're embarking on a deep dive into, well, a really critical discipline, prompt engineering. We're talking about the systematic design, the optimization of inputs for large language models. And this isn't just about giving simple instructions, is it? It feels more like architecting how we interact with AI.
That's a great way to put it, architecting interactions.
Yeah, to unlock those really sophisticated behaviors, it powerfully illustrates that old principle, garbage in, garbage out. Input quality really dictates output fidelity.
Absolutely. And I think a key insight here is that we're really experiencing a genuine paradigm shift. Natural language, just plain English in this case, has become the new interface for these powerful LLMs. So prompt engineering is rapidly becoming the crucial skill of the 2020s, maybe like coding was in, say, the 90s or 2000s.
That's a strong comparison.
Well, this deep dive, I hope, will reveal how these advanced prompting techniques provide what you could call cognitive scaffolding.
Cognitive scaffolding, like a support structure for the AI's thinking.
Exactly. It's the structured thinking process an LLM needs to navigate complex problems and to unlock its full latent capabilities. Things it can do but won't without the right guidance.
Okay, let's unpack this then, because I think most of us, listeners included, have probably had that experience. You ask a really powerful LLM something and you get back, well, a pretty generic or unhelpful answer. So what exactly causes these simple, maybe zero-shot prompts to just fall flat so often?
Right. Well, the mediocrity or sometimes just plain wrong answers you get from basic prompts, it isn't really the model failing per se.
Oh.
It's a more predictable result of weak conditioning. You haven't given it enough to work with. Common failure modes include, well, vagueness is a big one. A complete lack of context is another. Inconsistency in the output. And all this often leads to the infamous hallucination where the AI basically just invents information.
Yeah, makes things up. Not ideal.
Yeah, not at all. A vague prompt, you see, gives the LLM way too much uncertainty. It doesn't know exactly what you want, so it defaults to statistically common, often very generic, answers. Advanced prompts, on the other hand, provide strong, specific constraints. They narrow down the possibilities, reducing that uncertainty.
Okay, so constraints are key. How do we actually provide that stronger guidance then? Let's explore some of these powerful techniques that can transform those basic interactions. Where should we start? Maybe chain of thought. CAS reasoning.
Yes, definitely. CAS is fundamentally a method to make LLMs break down multi-step problems into sequential steps. It effectively mimics how humans often reason through things, one step at a time.
Okay, thinking step by step.
Precisely. And a really nice side effect is that it makes the model's reasoning transparent. You can actually see how it got to the answer. It offers you a peek into its thinking.
Clarity sounds incredibly valuable, especially if something goes wrong.
It is.
Can you walk us through an example, maybe that classic one, the Apple math problem, just to illustrate how a simple tweak guides the LLM?
Sure, yeah, that's a perfect illustration. So imagine the problem. I went to the market and bought 10 apples. I gave 2 to the neighbor and 2 to the repairman. I then bought 5 more and ate 1. How many apples did I remain with?
Okay, standard word problem.
Right. Now, if you just ask the LLM that directly, especially older or simpler models, they might just guess or add up the numbers incorrectly.
Right.
But if you add a simple phrase like, let's think step by step before the answer.
Just that.
Just that. It prompts the model to output its reasoning first. It might say, okay, start with 10 apples, give away 2, 10, 2, 8, give away another 2, 8, 2, 6, buy 5 more, 6 plus 5, 11, eat 1, 11, 1, 10. Final answer, 10.
Wow, okay. So that little phrase forces the sequential processing.
Exactly. And this method, COT, it's evolved quite a bit. From these simple linear chains, we now have more complex structures like tree of thoughts and even graph of thoughts.
Tree and graph, so more branching.
Kind of, yeah. It mirrors how AI search algorithms evolved. Instead of just one path, the model explores multiple reasoning paths concurrently, like branches on a tree, evaluating different potential solutions or intermediate steps.
That sounds much more robust for complex problems.
It is. The performance jump can be dramatic. For instance, on a benchmark called the Game of 24, which is a math reasoning task, Tree of Thoughts, using just 5 candidate reasoning paths, achieves something like a 74% success rate.
74%. And the basic approach?
Basic input-output prompting, that was down at about 7.3%. So a huge difference.
Huge difference indeed. Okay, so CoLT helps guide the AI's thought process, that's clear. But what about the output itself? What if you need the AI's output for integrating into other systems, not just text for a human to read?
Ah, yes.
Yeah.
That's another critical area. Structured output. This is incredibly impactful.
Structured output. You mean like forcing it into a specific format?
Exactly. Forcing the LM to return data in specific machine-readable formats like most commonly JSON, but also XML or others.
Right.
And this contrasts really sharply with the unreliability you get if you just ask it in the prompt, please format the answer as JSON. You often get, well, malformed results, things that aren't quite right.
Yeah, I've seen that. Missing commas, wrong brackets.
All the time. But with specific API features, things often called JSON mode, or techniques like constrained decoding, we've seen reliability just skyrocket from maybe 30–40% success with simple prompting to essentially 100%. The model must output valid JSON according to the schema you provide.
100% reliable. Okay, that's a game changer for automation. So for our listeners who are thinking about integrating LLMs into their workflows or tools, what's a common, maybe high-impact use case where this structured output radically changes things?
A great example is extracting information from text. Let's say you have a research paper abstract.
Okay.
Instead of asking for a summary and getting, varied prose each time, you can now reliably request a clean, immediately parsable JSON object.
With specific fields.
Precisely. Fields for, say, title, authors, publication year, maybe key findings. The LLM reads the abstract and fills in the structured data.
I see, so it's not just chatting anymore.
Not at all. This transforms the LLM from sort of a chatbot into a powerful reasoning engine that populates predefined data structures. And that's absolutely crucial for building reliable AI agentic systems.
Agentic systems, those autonomous AIs we hear about.
Yes, AI is designed to perceive their environment, make plans, and take actions, often interacting with other tools or APIs. Reliable data exchange is fundamental there.
Makes sense. You need predictable inputs and outputs.
You do.
Okay, one more technique. The idea of an AI that can critique its own work sounds almost like science fiction, but you mentioned self-correction.
Right. Self-correction is a fascinating development. It involves setting up a loop where the LLM generates an initial response. Then, in a subsequent step, it critiques that response based on certain criteria, and then it refines it using that critique. It's a kind of feedback refine loop.
So it's like the LLM is engaging in metacognition, thinking about its own thinking.
That's a perfect analogy. Metacognition for AI.
You mentioned an example with marketing slogans earlier. How does that play out?
Yeah. So imagine you ask for marketing slogans for a new eco-friendly coffee brand. The first attempt might be quite generic, like good coffee, good planet.
Okay, bland.
Pretty bland. But then you feed that back in, maybe with instructions like critique this slogan for memorability and impact, then generate 3 improved versions.
See?
The AI might then critique its own slogan as being forgettable. And based on that critique, it could generate much stronger options. Maybe something like sip sustainably or wake up to a better world.
It's much more creative.
Right. Definitely stronger. So it's great for quality improvement. Are there downsides?
Well, it's highly effective, yes, but one potential issue is self-bias. The LLM might be a bit too lenient on its own initial output sometimes. It doesn't always catch all its own flaws.
Okay. Needs careful setup. It does. But this technique is really a foundational step towards building truly autonomous AI agents. It's actually a core part of frameworks like React, where an AI sort of plans, acts, and observes in a continuous loop, refining its approach based on feedback.
This is fascinating. So, SATO, structured output, self-correction, what does this all mean for specialists listening in? It feels like these aren't just, isolated tricks.
Not at all. They form a powerful toolkit. And importantly, they can often be combined.
Combined? How so?
Imagine setting up, say, a simulated expert panel where multiple instances of the LLM use chain of thought to analyze a problem from different angles.
Okay.
Then perhaps use a self-correction step to refine their collective findings. And finally, output the consolidated results in perfectly structured JSON.
Wow. Okay, that sounds incredibly powerful. Complex, but powerful.
It can be. But the core idea is choosing the right tool or combination of tools for the job. If you need complex reasoning, SATO or its variants are probably the way to go. If reliability and system integration are paramount, structured output is key. For really polishing the quality of generation, self-correction loops can be fantastic. And for exploring nuanced problems, maybe that expert panel simulation approach is best. It really depends on the specific task.
So the skill becomes knowing which technique to deploy when.
Exactly. And looking ahead, the real frontier is probably automated prompt engineering.
Meaning the AI figures out the prompts itself.
Essentially, yes. AI systems that discover and optimize prompts or prompt chains automatically for specific tasks. Our role might shift again from crafting individual prompts to becoming more like architects of these meta-optimization systems.
Architects of the optimizers. That's a mind-bending thought. So maybe a final thought for everyone listening. Think about how mastering these kinds of techniques, moving beyond basic prompting, can truly redefine your interaction with AI. It feels like it could give you a real, tangible competitive advantage in whatever field you're in.
It absolutely could. And it raises an important, maybe even profound question for all of us, doesn't it? As AI gets better at engineering itself, how will our unique human creativity, our intuition, our problem-solving skills need to evolve? How do we best complement and, crucially, guide these incredibly powerful new tools?
A question to ponder indeed. How do we evolve alongside the AI? Well, that's all the time we have today. Until next time on AI for Specialists, bye-bye.